this here is an example of a reciprocal graph. This is actually the graph of y equals 1 over x. And you can see that there's something called asymptotes here. Now, asymptotes, there's an asymptote here, an asymptote here. So this line here, the blue line, will continue to get closer and closer and closer to this red line, but it will never actually touch it. So that means that this red line, which is x equals 0, is impossible. So x will never be 0 for this question. X cannot equal 0. And the same goes for this here. So here's an asymptote as well. So this blue line will get closer and closer and closer to the red line, but it will never touch it. So again, that line, which is y equals 0, the blue graph will never cross that. So y can never be equal to 0. So I can look at that algebraically, and that makes sense, because if I put x is equal to 0, 1 over 0, well, that isn't going to work. That's impossible. It will come up as math error on my calculator. And if I want to find out what happens when y is equal to 0, so I put 0 equals 1 over x and figure out what x is, again, I will end up doing, if I do a little balance method, times by x. X times 0 is 0. So that's technically saying that 0 equals 1, so that's wrong. So again, we can't do it. So that's why these are both asymptotes, because the graph will never be x equals 0. It will never touch x equals 0, and it will never touch y equals 0. So that's what an asymptote is. So I have this equation of a reciprocal graph here, and I want to know what the equation of the vertical asymptote is and the horizontal asymptote. So remember, vertical, horizontal. So the vertical one is going to be crossing the x-axis, so I know it's going to be x is something. So I need to look at this equation here and think, well, where is x impossible to be? Now I know that if I do anything divided by 0, I'm going to get math error on my calculator. That's impossible. So this bit here, I want to make it equal to 0. And to do that, I must have to make x equal to be minus 1, because minus 1 add 1 is 0. That's going to give me the math error on my calculator. That's what I'm aiming for. So x must be minus 1 at the asymptote. So if I draw that onto the graph here, I know there's an asymptote there. So that's the vertical asymptote. Now, the next one, so the horizontal one, again, I want to be looking for where it's going to be crossing the y-axis. So where is it impossible for it to be y? Now, if it was y equals 1 over x plus 1, now it would be just like this, very similar to the one that we've had previously. And it would be that it would be y equals 0, which would be impossible. And I can demonstrate that, because if I put 0 here, and I want to times both sides by the x plus 1, I end up getting 0 times x plus 1 is 0 is 1, which is not true. So that's that impossible bit again. Now we haven't just got y equals 1 over x plus 1. We've actually got y equals 3 plus 1 over x plus 1. And what I want you to think about here is going back to transformation of graphs and going back to the line in the cage. and how this point here, this 3, is outside the brackets because it's nowhere near the x, outside the brackets, so it's moving the graph up by 3. So it's outside the brackets, the line does what it you want it to do, and it can go up or down. So it's actually going to go up 3. So imagine moving this red graph up 3. It's going to look more like this. And instead of there being an asymptote at y equals 0, there's now going to be one at y equals 3. So the horizontal asymptote would be at y equals 3. This makes sense algebraically, because if I put y equals 3 into this equation, so 3 equals 3 plus 1 over x plus 1. The first thing I need to do when doing balance methods is take away the 3 from both sides. I end up with 0 equals 1 over x plus 1. And I get back to that issue of I'd have to times my x plus 1 by 0, which would give 0, and 0 is not 1, so that doesn't work. So my asymptote for the horizontal is y equals 3.